Okay, everyone, let's talk about correlation. Okay. Now, in 2010, there's a study reported examining the relationship between cheating and final exam grades in MIT. And what they found probably will surprise a lot of people. What they found was the more a student cheated during the semester, the lower the final exam grade. Right? Now, is it positive or negative correlation? Now, at this point, we should be able to know already. So there are two variables, right? The cheating is the one variable, and the more a student cheat, final exam grades is another variable, and it's the lower. So obviously, they are moving in opposite direction, right? This one more, then this one will be less. So that's negative correlation. Two variables are moving in a different direction. Now, if you are a researcher, what would you conclude? Which variable causes the other? You might be tempted to conclude that cheating causes lower exam. Maybe because cheating, they get a better grade or whatever, and they feel they don't have to prepare, right? But remember, correlation is not causation. Um, uh, there might be a third variable influence the other about this relationship. So we can never conclude one causes the other. Okay, as I said, correlation is a causation. But on the other hand, we can think about possible explanations and do more research. Maybe do experiment, which can tell us a causation if we control everything well. All right. So just remember, correlation is not causation. And also, probably don't cheat, right? Now, applying correlation, we need to remember these issues, reliability and validity. Okay, so to test measures and instruments reliability, we have some different ways. For example, test, retest. We give people like this test. We want to know if it is reliable, right? And then maybe a month later, we give them the same test again. Now, if this instrument or this measure is reliable, then these two scores should be highly correlated. So this is a test retest. Also, correlational coefficient alpha or covariance alpha. This is a measuring the internal consistency. The symbol is alpha. This is called alpha. It's measuring internal consistency of the test. There are 10 items, and those 10 items are measuring, reliable. I mean, they are highly correlated. All right. Also, validity. Now, validity is much harder to establish because reliability is measuring what the consistency of a test, right? Just like you step on a weight scale for 5 times, and it all comes out the same number. 130, 130, 130. 5 times. That's reliable. Now, this weight scale is reliable, but it's not necessarily valid. Have validity because maybe the person's weight is actually 150, right? So reliability doesn't necessarily mean validity, and validity is measuring what you're supposed to measure. In terms of instruments, it's not that easy to know if this instrument or this measure is measuring what it's supposed to measure. But one way we can do is this: see how much this new test correlates with an old test that is valid, right? So, for example, you develop this anxiety test. So you give them people this new anxiety test, and then also an old anxiety test that we already know that's valid. And these two tests should be highly correlated if it's this new test is valid, but should not be perfectly correlated. Because if it is perfectly correlated, then why do we need this new test, right? So this is applying correlation.